After you draw a couple Bohr diagrams, you start to realize that the inner rings don't really do a whole lot. For example, if you take a look at, let's say, oxygen, nitrogen, and carbon. So we're going to start off, draw a Bohr diagram of carbon. So for C for the symbol, and then 6 electrons. So you'd have 2 electrons and then 4 electrons for a total of 6. For nitrogen, it would be 7 electrons, so 2 electrons and then 5 electrons. And then for oxygen, the same, 2 electrons and then 6 electrons for a total of 8. So you start to realize that the inner shell always has to be full before the next shell is even occupied by any amount of electrons. So what we then need to do, or so what we can do is we can draw Lewis dot diagrams. And Lewis dot diagrams also help give us a visual depiction of how chemicals are going to react. So the only difference is that you don't include the inner energy levels, and you only draw the outer, and you draw them as dots. So for carbon, there's 4 electrons on its outer, and you draw it as dots. And for nitrogen, there's 5. Now here's the only thing, there's room for 8 in this shell, and you have to draw them one at a time, going around either clockwise or counterclockwise. And it's not a big deal, but they all have to be spaced out. So all 4, you'll notice, are just in their own respective corner. And then we start to double up on the 5th. So then the 5th electron gets paired, and that's going to become important later. So for oxygen, there's 6 in the outermost, so we start off 1, 2, 3, 4, and then we start pairing 5, 6. So it has 2 unpaired electrons. And that's how you draw Lewis dot diagrams.